Thank you, Kennedy. And right now it's time for that time when we have our special guest. Tonight's special guest is Dr. David Krofcheck, Senior Lecturer in Physics at Auckland University and the New Zealand connection to the Large Hadron Collider at Cern in Switzerland. When it comes to physics, this is the place to be. We welcome Dr. David Krofcheck as our special guest on The Beat Goes On. David Krofcheck, welcome to The Beat Goes On.
Thank you, Gerard.
I detect there with my accent detector an American accent.
I'm afraid being here 15 years, I have not lost the American accent.
Now, two things we want to talk about before we continue. Number one, you are a baby boomer. You've just scraped in. You're 50. You were born in 1958.
That's right, 1958, and I've just been privileged enough to make it in.
And also you're at Auckland University, a senior lecturer.
Senior lecturer in the Department of Physics since 1995.
Now, you're here today because it's an exciting time with physics at the moment, and we're talking about the Large Hadron Collider. Now, many people will say, what on earth is the Large Hadron Collider?
It has a very strange name. A hadron is a very complicated way to say protons. And if you think back to your high school days, you had protons and neutrons in chemistry class. Yeah. This is a very large, the world's largest particle accelerator colliding protons head-on to counter-rotating.
In Switzerland.
Geneva, Switzerland, underground. It's like the tube in London. It's 100 meters underground, 27 kilometer
right around, it's a big track.
And you can't tell from the surface that there's anything there. It looks like farmland.
But underneath, there's 27 kilometers, there's these photons racing around near the speed of light.
That's right. The protons are accelerated to just a whisper of a hair away from slower than the speed of light. And then at 4 separate points, they're made to collide. And then we build gigantic radiation and particle detectors around those points, and we try to figure out from the debris of the collision what kind of physics must have happened.
Yeah. There is a New Zealand connection, and you are leading that New Zealand connection. Is that correct?
That's right. Yeah. It turns out that when the Large Hadron Collider was being first constructed, a local fellow, Alec McPherson, who now has a very responsible position running the accelerator from Ashburton, he was at a barbecue in Switzerland, and they asked Alec, well, where's New Zealand in this array of 80 countries or so? We don't see New Zealand anywhere. And Alec was at a loss to explain what happened and where we were. Well, Alec's made a few contacts with folks back at Canterbury University, where he graduated, and they learned about this strange American fellow who'd just been appointed at the University of Auckland. And Alec and I and our families met together down on his mother's back porch in Ashburton over a Christmas holiday, and we discussed how we could get New Zealand involved in this giant science project at the Large Hadron Collider.
All the other countries around the world, they set up the system where the photons would race around, bang into each other, but New Zealand's role was to help in the building of the detectors to see what happened when they did collide.
That's right. We built one special part that kind of looks after the more expensive parts of the detector, kind of like the canary in the coal mine. So if our detector sings out, we know there's something wrong, and the beam is diverted into a beam dump and doesn't hit our major detectors. We're looking for the best collisions possible, which means that our New Zealand detectors should not give big signals. If they give a big signal, that means the proton beams that are going around have gone off target, and they're not only missing each other, but they're starting to hit the giant radiation detector that all the other countries helped put together. This is not good.
Very complicated, isn't it? Very complicated.
But very exciting. It's working. It actually works, and people rely on New Zealand now.
What have we discovered so far?
We have basically established that, first of all, this enormous project actually works. New discoveries, well, that's what's happening.
Yet.
Well, it's starting to happen now, because now, instead of colliding protons, right now, we are colliding lead nuclei, which are just common lead. When you think of lead, so this is 208 times heavier than a proton.
When are they going to discover the warp drive?
The warp drive, ooh, my favorite science fiction show, Star Trek. Probably.
Don't give us the details, give us the warp drive.
Give us the warp drive. I'd love to have one. It would make traveling to Geneva much more smooth.
Yeah.
That's probably not going to happen for quite a while. Maybe our great-grandchildren will have to look into that.
Yes, exactly. And every time you peel the layers back, there's another mystery below that, isn't there?
Yeah, that's the way it seems. And we're looking for even another layer smaller than the quarks. There's no indication of anything smaller so far. It's an open question.
Yeah.
But that's one of the first questions you ask when you have a brand new toy, a brand new particle accelerator at new high energies. You always ask that same question.
Have you yourself got a cherished quest or a search for something that you've given it a lot of thought to? Is there anything that you would love to know the answer to?
Yes, I would actually. It's not a really popular topic because the more conservative physicists will say, oh, this is just another crazy idea. But it turns out that you can take our world, our front, back, up, down, left, right, and time, our 4 dimensions that Albert Einstein dealt with, and expand those to many more dimensions, maybe 10, which is the next safe bet.
There's more dimensions.
Many dimensions.
Yes.
But where are these dimensions? Where do they go? Why do we live in just 4 of them? There is an indication, there's a mathematical connection between these heavy ion lead-lead collisions and multiple dimensions. If we can study closely enough the behavior, the science, the way these heavy nuclei collide and the way the quarks and gluons inside move, that might be related to the 10 dimensions
that could be out there.
That could be out there. And this is one of the things that's really on the edge of science.
Yeah.
And it's a question that people cannot positively shoot down. So we just need these measurements at the Large Hadron Collider to see whether or not we can shoot this hypothesis down.
Now today you're a senior lecturer at Auckland University. What's the, what are you feeling from your students? Are they enthusiastic about their future as physicists? Is there a, what are you getting back from young people coming into science today?
I'm getting a feeling that people are really looking for job security. And a lot of our students are looking for engineering careers, for example. And so we get a large number of students who take the physics and then try to get into an engineering program. But on the other hand, when you talk to these folks a year or 2 later, they tell you, you know, Dr. Krofcheck, I really loved physics, but my parents insisted I go get a job. And so I really loved talking about nuclear and particle physics and astronomy and cosmology and the nature of the universe and how it works. But my mother would say, but then who would you pay you to do this?
Yes, exactly.
And so I can't blame them for that. So we try to train them as best we can in problem solving, knowing basic rules of science and physics, and they can take off from there.
So what you're saying, there's only basically a few positions for Einstein-type people who sit and think on the top of a hill.
Very few. Well, and on top of that, very few people. There are only the rare Einstein occasion.
Yes.
Most of us sit at our computers and look for data, or we sit at our chalkboard, whiteboards now, and scribble equations on the board if you're a physicist.
Who is considered in your community, who would be considered the Einstein of today? Give me a name. Well, give me 2 names.
I'll give you a name. Edward Witten, Institute of Advanced Studies, Princeton University.
He's considered the Einstein of the day.
Yes, I would say that he's probably up there at number 1. There are numbers of other people who could arguably be number 2, 3, 4.
There's always one every generation.
But I would say Professor Witten, simply because of the deep way he is looking at the nature of the universe, whether it's smooth or whether it's quantum grained, and the mathematics of multi-dimensions. This is a man who's discovered a type of mathematics that's essentially 100 years ahead of us, and we don't know what to do with it right now.
Coming to work every day, exciting. I mean, you've got a job.
Wonderful.
It's just a wonderful job, isn't it?
It's wonderful. This being a university lecturer is just the best job. You get to sit and think about problems you love, and you're paid to do it.
Yeah.
And I would do it. Well, I would do it for less money. My wife would not want me to hear this.
But it's such a great job.
Yes, and I've been doing it for such a long time, and you meet so many wonderful, like-minded people around the world. That's the other major reward. Besides doing the job for itself, you meet like-minded people from all across the planet. People who are basically asking the same questions, and they have the same inner drive to understand, and they're multinational. And I'm glad New Zealand is now part of this.
The hydrogen atom came from the Big Bang.
That's right.
The Big Bang. And all we had was just a huge bunch of hydrogen. That was what was created, supposedly, in the theory. And I'm just thinking to myself, we don't give this hydrogen atom the credit that it deserves. It is just amazing how it's created the whole universe, hasn't it?
Yes.
One little atom.
Yes.
I've always said, if supposedly they say that God created the world in 7 days, I think God knocked off on Monday afternoon around about 1 o'clock and said, I've done enough. I've just developed the hydrogen atom and it will do the rest. He didn't have to do anything after that.
You just give it a little push, and then it does the rest, yes.
Well, it has done everything, hasn't it? The hydrogen atom.
Everything we are made of out of today has come from some sun that is exploded 10 billion years ago.
Yeah.
And all of the elements in our bodies, all of the carbon and nitrogen and oxygen in the air, these all started off as hydrogen atoms, and then now inside those hydrogen atoms, quarks, and what holds together quarks? Gluons.
Yes.
So now we're able to even crack open this fundamental element of nature. And that's what we're studying at the Large Hadron Collider. It's the primordial creation.
And before hydrogen, nothing.
Well, that's what we're trying to study. We're trying to understand what could have been before.
Yeah.
This work touches on, for me, fundamental questions of how we started off, and everything that we know of blossomed from that very beginning. We're talking pushing the knowledge back to a few millionths of a second right after the Big Bang. These are the kind of conditions we're creating at the Large Hadron Collider and studying the physics and the properties that the universe must have had to have produced what we see here today.
I think that the greatest question of all is, with all your colleagues in Switzerland and in Auckland University and everyone you've met, could you make a stab? What's the percentage of, because it does make you think, the philosophical side. Was the Big Bang created by somebody else, or was it just a random occurrence? Do you think there was a design behind it? Or, I mean, it's the ongoing, it's the biggie. This is the big argument, isn't it?
Yes.
What's the feeling amongst all your colleagues, and what would it break down to? 60% feel that there's something bigger behind it, or it was just a random occurrence?
I think if you were to ask physicists, you probably would find a larger percentage giving the random occurrence answer. Personally, I'm Catholic, I'm Christian, and I feel there must be something more than what we see. And this is my personal feeling, but it doesn't put down anything about the possibility that this could have been a random event. The
philosophy can sometimes get into the way of the actual pure hard science, can't it?
That's right. The physics is a very, very harsh mistress. And if you let your philosophical leanings or desires become involved in the analysis or interpretation of the data, that opens you up to criticism in which you can be easily refuted. And you want to make your science as clear and as unambiguous as possible without extraneous interpretations added to it.
Dr. David Krofcheck, it's been fascinating. And thank you for being with us on our 100th show.
Congratulations on your trip.
Thank you.